We're going to look at a little bit more of solving equations here and also explaining steps for how we are rewriting and solving equations. So the first few problems are related to solving multi-step equations, which we've been working on a little bit. I have already written down the steps that we have talked about in class, but also provided some examples of the process in which you go through and what that would look like. So when we're solving multi-step equations, oftentimes we are looking for the distributive property to be used first to do a little simplifying, then combining like terms, whether they're on the same side of the equation or opposite sides of the equation. We like to do that second. And then we undo any addition or subtraction, and then we undo any multiplication or division, and eventually we get to the actual solution. Since this was all written down ahead of time here, if you want to pause the video now so you can write this down, feel free to do that. I will start talking about the first problem that we see below next here in a moment, so feel free to pause now. Okay, so we're going to solve the equation in A here using the process that I talked about above. So this particular problem does have some distributive property. I like to draw a line down regardless of whether we're undoing from both sides first, just to kind of have that organizational structure. Keeping organized is always good. So the distributive property that we're talking about here would be to multiply that 3 times both terms inside the parentheses. So we have 3 times x, which is 3x, and then 3 times 7, which is 21, which equals 5x plus 27. All right, so the next step in my list is to combine like terms. Now in this case, we have some x's in the equation that are on opposite sides of the equation. Sometimes they're on the same side, sometimes they're on opposite sides. So let's go ahead and combine those, but to move it from one side of the equation to the other does require undoing it from one side. So in this case, I'm going to undo the positive 3x by subtracting it and moving it to the other side of the equation to balance out the subtraction on the left side. So that cancels out the x's on the right side, on the left side. 3x minus 3x is 0. And so we'll bring down what is left here. Actually, I'm just going to keep my red here just so my combining like terms is all in red. And then we've got 5x minus 3x is 2x plus 27. Okay, so now I get to the step where we are going to undo addition or subtraction. So I'll switch over to green. So my variable is on the right side, so I'm going to undo the numbers that are with the x on the right side. So we'll start off by undoing the adding of 27 by subtracting 27 from both sides. So that leaves me with 2x equals 21 minus 27 is negative 6. So negative 6 is equal to 2x. And then we will undo any multiplying or division. On the right side, I have 2 times x. Remember, 2x means 2 times x. So 2 times something is negative 6, which you might be able to do in your head. But we will do the operation, the undoing operation of undoing that multiplication with division. So 2 divided by 2, which is 1x, or just x. Negative 6 divided by 2 is negative 3. So negative 3 is equal to x, or you can just flip it around and say x is equal to negative 3. Either way would be fine. I guess oftentimes we might prefer that second way of just writing that variable on the left is equal to the number negative 3, the solution negative 3. Okay, part B here, let's go through those steps again. So looking for distributive property here first. I don't see any distributive property. I don't see any parentheses where there's a number in front. So we'll actually go to step 2, which is combining like terms. We've got a bit of this. We've got some x's on the same side of the equation here first. So we've got 5x minus 2x, or 5x plus negative 2x. If I put these together, that would be 3x plus 10 is equal to 18 plus 7x. And I guess I still have some combining like terms that I might consider because I have x's on both sides of the equation, much like part A. So to keep things positive, I'm going to subtract that 3x over to the right side, so subtract it from the left. I could also subtract 7x and from both sides, but that would leave me with a negative 4x on the left side. So I like to keep things positive if I can. So 3x minus 3x is 0, so we just have 10 is equal to 18. 7x minus 3x is a positive 4x. Okay? And now we'll go ahead and undo any addition or subtraction that is on the same side of the equation with the x. Now, when we're talking about that, we're really talking about the number that's being either added or subtracted from the x term, which is the number that's kind of sitting on its own. So this 18 is what we were referring to there. It's a positive 18, so we're going to subtract 18 from both sides of the equation. 18 minus 18 is 0. So 10 minus 18 would be negative 8 is equal to 4x. And then we will undo any multiplication or division. This is 4 times x, so we'll undo by dividing both sides by 4. 4 divided by 4 is 1, or 1x. Negative 8 divided by 4 is negative 2. So again, if we want to just rewrite it so we have the x on the left side, then x is equal to negative 2, or negative 2 is equal to x. All right, we have one more here. Once again, on this one, I don't see any distributive property that we need to use. So, where's my straight line? Let me try that again. I like how notability makes my line into a nice straight line like that. Okay. So we're going to not use the distributive property, but we do have some combining like terms again. So on the right side of the equation, I have this minus 2x. I have a minus 7x. So I've got this term and this term that I'm putting together. So negative 2x plus a negative 7x, or negative 2x minus 7x, is a minus 9x. And in this one, I also have some like terms with the numbers positive 3 and minus 20. So I could also put those together. 3 plus negative 20, or 3 minus 20, is negative 17. Equals negative 62. Okay. All right, so now let's undo any addition or subtraction. So on the same side of the equation as the x, I will undo the subtracting of 17 by adding 17 to both sides. Bring down what's left. Negative 9x. Negative 62 plus 17. Careful with your negatives here. If we take negative 62 and we add 17, that means we're getting closer to 0 by 17 spots, which gets us to negative 45. If you were living in Alaska, maybe you'd have a negative 62, or maybe Antarctica, negative 62, and it got 17 degrees warmer, you'd be all the way up to negative 45. Ooh, put on some shorts. All right, so I don't know why I switched colors there. I was going to stick with green. I don't know why I switched back to red. I'm going to color over that. Equals negative 9. All right, so then undo any multiplication or division, which is my purple color. So this is negative 9 times x. So I will undo by dividing both sides by negative 9. Remember, not just 9, it's a negative 9. Negative 9 divided by negative 9 is 1, or 1x. And negative 45 divided by negative 9, a negative divided by a negative is a positive 5. So I'll rewrite that as x equals 5 here. So that would be the solution. So as you go through solving these, and I guess we just had one here that used the distributive property, but this is normally the process, the steps that I'd like to use, and the order in which I like to do the solving.